So we want to talk about data science from slightly different viewpoints. So we want to discuss what is AI, artificial intelligence. Okay. So in the old days, right? So we just say artificial intelligence. We want to make some kind of program or device, right? Right. So to make sure that you know, in the end, right? So that device can perform something that uh, people can perform, right? So if we can get something better than human, right? So then we say, oh, maybe that device got some kind of intelligence, right? So if you check the AI textbook, right, and we are going to have four different categories that they are all belong to artificial intelligence, right? So on the top, right, these two parts, right? So on top, right? So we are going to say, okay, one part is that we say thinking humanly and thinking rationally, right? So it's all about thinking, right? So we want to build a machine they can think, right? So either that on the left hand side, okay, we want to say, oh, thinking like human. On the right hand side, we want to say thinking in the right way, right? So we all know that, the rational and the more thinking like a human may not be the same thing, right? Sometimes that the human may do something not rational, right? So usually, right, if we want to ask machine to do something, maybe we want to focus more on the, thinking rationally, right? So down to the bottom, it's all about action, right? So on the left, that we say, oh, acting humanly, right? Acting like a human, right? On the right, we say acting rationally, mean that acting in the right way, right? So uh, probably you can imagine that in our course, right? Also, I'm not kind of, people doing maybe robotics, right? So maybe we don't care too much about acting, right? So we care more about thinking. Still, that we need to know sometimes thinking and acting may have a gap in between, right? Okay, and also I want to emphasize is that between the left two cells and the right two cells, right? On the right is more like a rationally doing something, right? On the left is like doing something like human, right? So maybe we want to uh, spend more time on like rationally doing something rather than doing something like human, right? But this is not a clear cut, such as that if we want to use data, right? We want to collect some data to analyze a human behavior. Like let's say if we want to analyze how many people going to convenience stores, right? To these days, right? You come to Taiwan, probably you see a lot of convenience store everywhere, right? So you can get a lot of things from convenience store. So maybe we want to analyze how many people and what kind of transaction, how many like how much profit that they can earn for each convenience store, right? So for this kind of task, right? So of course, it's very clear, right? So we want to say, oh, maybe we can focus on thinking rationally, right? But it's not quite the only thing that we care, right? So just because the people go to convenience store, just because they want something, right? So it's related human, right? So maybe we also need to think about, right? So for instance, the raining days, right? They don't go to convenience store so often, right? So that's a human behavior, right? So it's not like a rationally we do something, right? And also sometimes the convenience store may have some kind of promotion, right? So there'll be more human going to that convenience store, right? It's not also not quite like we can easily say it's a rational behavior, right? Okay, so but no matter what, I would say most of the time we focus on thinking rationally, right? Okay, but still we want to take a few moments to go through all different categories, right? Such acting humanly, right? So usually people maybe one example is that we talk about Turing test, right? So Turing test is that we say, oh, we want to ask someone communicate the other side, right? The other side could be human, could be robot, right? So after a few moments, right? So this person on the right, we want to say, can this person tell that the other uh, side, right? Opposite to the next to the wall, right? Would that be a robot or agent or real human, right? So if you can tell, right? So that means that if you can tell it's a robot, right? That means that robot doesn't pass the Turing test, right? So it has been, let's say, more than half century ago, right, when Turing proposed this kind of task, right? So then at that time, the human predict that by Y2K, right, it's already passed, right? So the machine can uh, may have the 30% chance to fool a person for 5 minutes, right? So we are not quite sure about this, right? But we can say that these days, right, based on, for instance, if we talk about deep learning, right, deep learning can really learn something to speak like a certain people, right? Like speak like Donald Trump, right, from USA, right? The former president, right? Or something. Sometimes we can ask a person, ask a computer robot or agent to behave like a human or maybe speak like human, right? That's also possible to do these days, right? But if we talk about the content, probably still very difficult to mimic what people can say, right? As you can see that from Siri, right? Probably you don't. Most of the time, you are not satisfied with Siri's output, right? So if we talk about thinking humanly, right? So this, in the old days, actually, when I was doing my PhD, actually I deal with, the so-called illusory figures, right? So down to the bottom to the left, right? So we see that probably you're going to see one square in front of four circles, right? So people may have this kind of illusion, right? So the machine or maybe model, maybe some device or some code that can see like us, right? The code or the program, the model may not be necessary for that model to behave quite similar to what we can see, right? Like to see one square in front of four circles, right? We know that's not true, right? It should be like for Pac-Man, right? Yeah, so what things that we want the machine to behave, right? Or to think, right? Either to think quite like human, then we need to pay more attention to cognitive science, right? Cognitive science, right? So otherwise, maybe we just need to make sure that what we can see is as close to the truth as possible, right? So such as that from time to time, we're going to have a captcha test, right? So on the button to the right, right? So we're going to see sometimes these days, right, for your information, right, a lot of captcha tests has been passed by a robots, by agents, right? So which means that probably it's very difficult to design a good captcha test so that they can have a better result, okay, like to separate between a human and robot, okay? So if we talk about thinking rationally, we know laws of thought, right? So usually, let's say the example will be, let's say Confucius is a man and all men are mortal and Confucius is mortal, right? Like this kind of three steps derivation, right? So as you can see that this kind of thing will be used a lot when we design our machine learning or computer program which can have a good prediction to the future, right? Actually, even looks like this kind of that we later we're going to talk about induction, right? Given data, we want to build a model, right? Sounds like it's up to us to get some different result, right? But still, I want to emphasize many of the mechanism, right? Many of the machine learning codes, right? Is still based on laws of thought, right? Okay, so just that maybe one thing we can emphasize that this law of thoughts, right? Sometimes it's not like 100%. It's not like 100%, right? So also that sometimes it could be described probabilistically, right? Okay, and acting rationally, sometimes the difference between acting and the thinking is that sometimes the some emergency situation, like you see you touch something hot, right? So uh, your hand will going to come back to you, right? So it's not like you it's not, you don't need to think for this kind of behavior, right? So as a machine, right, the machine also need to do something in some emergency situation, like the machine doesn't need to always ask for some some intelligence output to give the feedback or to behave, right? So acting between acting and thinking will be different in this uh, kind of situation. Okay, so then we talk about between artificial intelligence and data science, right? Or maybe artificial intelligence and the machine learning. So we are going to say maybe, okay, if we talk about artificial intelligence, right? So actually, that consists of if we talk about intelligence, right? So maybe we can roughly say, okay, deduction and induction, most of both will be important, right? So in my words, right, we say deduction is to produce more rules, right? It's like from mathematics and physics, right? So induction is more like more rules to less rules. It's more like a social science biology, right? Okay, so between the difference between deduction and induction is that in old days, right, people really design a lot of programs or code, right? Which can do a lot of deduction. So one famous example is like the AI or program can easily do uh, finish a calculus test, calculus exam, right? With close to 100, like four grades, right? So this kind of ability usually will rely on deduction ability, right? Okay, but these days, right? So usually we care more about induction, meaning that maybe given tons of data, right? How we can draw conclusion from the data, right? So we also call this AI, right? But it's more related to a data-oriented approach. Okay, so uh, probably you see some Chinese characters, right? It doesn't matter that I want to just give you some example that say for computer to do induction, right? So usually we rely on a few examples, right? Some data, given some data, we want to draw conclusion, right? So after that, we are going to use the conclusion to test for some future examples to see the conclusion that built in the old days can still be can still be correct in the future. Okay, so we come to the definition of machine learning, right? So the machine learning is actually we use a computer program to learn something. What do you mean by learn something? To learn something means that we have got the experience E, right? The experience E usually is data. Okay, is the data. Okay, if we come down to some kind of input, there'll be data, right? So given a lot of data, right, then we can do what? We can finish a task. Okay, T, finish a task T, right? Then how good that we can finish a task, right? Then here comes some kind of performance measure P to evaluate, right? Such as that if we want to uh, evaluate your learning on this course, right? Maybe we are going to give a test, right? And then we check the grade to say what kind of performance you have, right? So that'll be a performance measure, right? Then machine learning, machine means automation, okay? Learning means that the performance is improved, right? So after a few data has been observed, right? So the machine can become smarter and smarter than before, right? Okay, so then people give a lot of different definitions such as maybe modification behavior can give us something better result based on expertise, right? Okay, and also uh, the learning machine. Maybe you can check this one. Learning machine is something that we can say the action is influenced by past experience. Past experience is that we say mainly due to the data, right? The data that we can observe will give us different uh, result. Will give us different influence on future actions. Okay. Yep. And also something later maybe we are going to pay more attention to is that okay, so we are going to build a system based on some some inputs, right? So later we are going to give some similar task, okay, maybe the same task, right? Then can we do behave something similarly, or maybe we can perform something similarly, right? So the things is that we want to emphasize same population. Same population means that if we want to predict, the weather for NTUST tomorrow, right? So we're going to collect a lot of data, right? A lot of past data that belongs to NTUST's weather, right? So we don't just collect the data that's say from Tainan or New York or some other cities, right? Okay, that doesn't help us, right? So we need to make sure that the data are from the same population, same distribution in this way, right? So these days, people really talk about, if we do have some kind of slightly different population, can we do things similarly, right? So here is something that usually we call what? Okay, so then we're going to say something that we care in this case would be that we say the transfer learning. Transfer learning. Okay, so transfer learning means that we may have some kind of things, some kind of old uh, old population of data, right? So the new data could be like this, right? New data could be like this, right? There'll be some place, to share, to overlap to each other, right? But we want to say, what can we draw, useful conclusion based on we know a lot of old data, right? Plus some, some tiny new data, okay? Plus the overlap area, right? Can we get a good result? Can we get a good model based on this whole thing, right? This whole thing, right? Remember that we have a lot of old data, okay? But we only have limited new data, okay? And there'll be some overlap to each other, right? So that's almost like we want to say that's the goal for transfer learning, right? So maybe we can have a way, find a time to focus on this in the future, right? Okay. So we talk about the definition of AI, right? So and as you can see that there will be a lot of things. All the machine learning or all the AI these days, right? Most of them focus on the data-oriented approach, right? That's why we say learning. Learning is that we are given data to build a model, right? So before now we talk about training, right? Training and learning is almost the same meaning here, right? Then based on the learning, we can build a model. We can try to find the best hypothesis, right? And actually, to build a hypothesis meaning what? Meaning that we estimate parameters, right? So what we can focus is more like the following, right? So maybe suppose, okay, suppose we got a program, right? So maybe we write a program. Maybe we write a program, okay? So before now, we write a program that say it's a learning program, right? So maybe later when we got data, right? Maybe I can draw like this. The program will be in the middle, right? The data I mean, so some input, right? Some input, okay? Okay, one piece of data, right? X, right? Then we can get Y, right? Given it's a model, right? In the middle, right? So before now, if we zoom in the model, it would be like what? Okay, the model is like this, right? If we zoom in, right? Okay, there'll be a lot of statements, right? Okay, but what is different from the, the old model and the modern machine learning model is like, okay, the machine learning model, if we say it's a machine learning model, that will have a lot of, empty space, like empty space, okay? Those empty space will be, oh, let's say, oh, maybe the first one belongs to the alpha is one kind of parameter, right? Another is beta and gamma, etc., right? So later, we are going to feed in those, like alpha maybe equal to zero point 0.1, right? Beta equal to 5, right? Maybe gamma equal to 3, for instance, right? So how to decide those parameters will be what? Up to a program, okay? There's a data, okay? Based on the training process. Based on the training process, we're going to decide, those different parameters, okay? So after that, in the end, we have all the things filled, right? They'll become what? Will become a complete model for us to do a prediction, right? So that's the basic concept of learning or maybe a parameter estimation, whatever you want to call that, right? So before now, we base on, expert to help us to decide those parameters, right? Not anymore, right? Because the expert may not know all the things, right? So data may know all the things because data will actually collected by different people, different for different situations, right? It will be more broad to just single expert, right? Okay. So and also we also mentioned that before now those parameters may be decided by some statistics, right? So we are computing those parameters based on some simple computation, right? Maybe not anymore, right? These days those parameters will be, if you still remember, right? So we talk about, we talk about what? We talk about, yeah, sorry about that. I should let you see it. Yeah, so to talk about what? To talk about, let's say, okay, now the program is more like a loop, right? More like a loop, okay? The loop, after we execute this loop, right? So we're going to get a better, you know, uh, parameter like alpha, beta, and gamma, right? So before now is what? Before now is, those parameters will be decided by a statistician, right? Not anymore, okay? Maybe more robust, right? They'll be done by a program based on what? Based on the procedure, iterative procedure, okay? Yeah, so we have all kinds of applications, right? We can have you know, a machine to play chess, right? We have we got a Tesla to for autonomous driving, right? And we also some people in the CMU actually built a robot snake, right? They can twist their angle for different places to perform quite like a snake, which can climb a very high wall or maybe going through to go through different services. Okay, and also for me that we have done something that belongs to data science is that okay, actually we collect a lot of human playing uh, online games. Also, they generate different trajectories, such as they going through different uh, playground, different locations, different area in online games, right? Like a map in a map, right? They going around, right? So we those people players generate trajectories, right? So we want to analyze that to see if they can, separate from other kind of, robot, right? We say bot or robot, right? They are not real human, right? But they can also play online games. Sometimes they die very quickly, right? But they can play so many times to get some benefit over real humans, right? So we want to detect that kind of unlawful users, and actually we analyze, the trajectory belong to human users or bot, right? We're going to see very different pattern, right? Such a human usually going around, right? Different area from one place to the other place in some very different paths, right? The robot will be always like a motorcycle straight from one place to the other place, right? Very like, very strict, right? That kind of following some kind of a pre-decided rules, right? And also we analyze the mouse traits from human and also from animals, right? To see if they can give us different information. Okay, and also we analyze, the car driving path, right? To see and also belong to the traffic, the speed, right? Can we detect any kind of, anom anomaly, right? Anomaly means that there will be some kind of accident, who knows, right? Then the cars will slow down, right? Can we detect that, right? Okay, so that belongs to anomaly detection given the traffic data. And also we analyze, the weather data. Oh, sorry, not weather data. This will be the traffic data too, right? So we're going to analyze between Monday, Tuesday, Wednesday, Thursday, etc., right? To see that the traffic speed sometimes they go down just because the heavy traffic, right? So we're going to say, can we find out some kind of periodic behavior belong to different weeks or different days, right? To see later that we want to predict the future, right? From one place to the other place, how long it takes, right? Okay, and also we can predict let's say the weather belong to different the sensors, right? Collect the data from different locations, right? So during the day, right? During around noon, then we will have a high temperature, right? Okay, but we going to have a daily periodicity, and also we have a similar pattern for different locations, right? Can we borrow the information from one place to the other place so that we can do the data imputation? And also we can use computer program to help us to analyze, phishing website, right? So to say between different website, can we detect one is could be the legal one, the other will be from, some illegal return website, right? Can we detect that? Okay. So one thing I need to share with you for this part is that we know the data science is very important, right? Why it is important? Just because data science will give us, the bully, so that the machine learning can actually use that bully to build model so that they can finish some predefined tasks. Okay, but sometimes we don't really need to say data science. We must have a predefined task. Sometimes we don't really know what's going on. We just got the data, right? So I also mentioned that, in our previous uh, recording, right? So we say the difference between uh, data mining and the machine learning, right? So the difference is that your data mining usually they don't have a clear goal, right? For machine learning, they have a predefined task to solve or to conquer, right? So that's the difference, okay? So the data science, of course, is not just covering machine learning, right? They also have some other part like data mining, right? And what we need to emphasize is still, data is the most important thing, right? So probably in this course, right, you're going to do some mini projects, right? So you need to think about where that we can get the data, acquire the data. Usually, uh, as you as you are beginners, right? Maybe you are going to get the data from some public domain, right? But in the end, maybe in the future, right, when you join a company, usually the company will collect the data by themselves, right? So that's why they can have a private data to get some hidden or a magic formula like other company may not have, right? That'll be their niche, right? Okay, and for information, the AI machine learning these days, right? So given the data, tons of big data, right? So we can get a quite good result in several fields like computer vision or speech recognition and text mining, right? So usually those three fields, right? So we need what? We need we need we for these three fields, right? So we need deep learning. We need deep learning. Okay, and then some student also asked me, can AI conquer human, right? So it's not just about this conquering something, right? And the human and machine can work together, right? So as you can see, this for these days, right, the human and machine still have a very like a complement ability to each other, right? So why not just let the machine and the human work together? So maybe we're going to have a better model in the future. Okay, so that's all for this part of uh, the materials. Thank you for joining us.